this video, we're going to try to get our ant colony to be able to communicate across iterations. So right now we have this version where we can kind of run it and it collects data with all the ants traveling around the different cities and it finds the best path. In the ant colony optimization algorithm, what we would do at that point is update the pheromone trail with the best path information and basically update the environment. And then the next ants that go in the next iteration would leverage that information by being more likely to travel paths that have a high amount of pheromone. But for us to be able to do that, we need to keep track from iteration to iteration which solutions were the best and therefore how much pheromone is on each trail. And I'm not quite sure how to do that. So the first thing I was going to do was I created this new file called runtsp.py, and I noticed in the tutorial here they're just calling model.step, right? So I think we can step through the model until each ant has been to all of the cities, and then at that point we can collect the path information for each ant and update this kind of global pheromone thing on the graph and then pass that back in for the next run. So in that way we can kind of step through the model, extract data, and then reinitialize the model with that data for the next steps. So that's the plan anyway. That may not be the best way to do it. We shall figure it out. Okay, so we have this file, we've imported our model, we have our parameters here. So I actually need the same number of steps as there are cities, since each ant travels to each city. And then okay, I'm just going to see if this works. We don't need to run our app. Okay, Python run tsp.py. Let's see what happens. Okay, so first of all, that was much faster because when we run the app, the frames per second must be set somewhere and I can't figure out where. So it steps through really slowly, and it would take forever if we wanted to run this many times back to back, because by definition we need to do this sequentially because each run updates the pheromones for the next run. Okay. Cool. Well, that solves two of our problems at once, because I briefly looked into how to adjust the frames per second on our app, and I could not figure that out. And I'll show you what I mean real quick. So if we run it, you see it's like 1, 2, 3, 4, 5. It's like 1 frame per second. And that must be set somewhere. And I know that if you set it to 0, it goes as fast as it can, but I can't figure out where to set that. We'll get rid of our app. Okay, run TSP. Okay, we can also get rid of this print statement. That's kind of contaminating things. Let's see, where does that happen? New best path found, right? So this happens at the very end. Distance 12. I'm gonna see if I can get just this last. Okay, great. Wow, so here the best distance is 10. Wow, that's much better than the rest. Okay, cool. So let's turn this into a function where this will execute one round of the traveling salesman and then return, I guess, the model. And then from that we can extract what we need. So one iteration, model params. Put a main guard here. Okay, everything's working. Eventually we'll parameterize this through configuration document or the command line, but for now we're just going to hard code things. Actually, to that end, looking ahead a little bit, okay, number of iterations, or should we call it number of episodes? Okay, so now what I want to do is run this multiple times. Let's say E in range number of episodes. Oh, here we have this best distance and best path. So let's have a check here where we keep track globally of this information. If model.best distance is less than best distance, then update it. Let's see, new best distance. Comment this out. All right, let's see what happens when we run this 20 times. Now, there's no communication between each run yet. Interesting. I'm going to guess that this is because it's using the same seed, right? Which is a good thing in the sense that we don't want a different city or a set of cities, because our seed is determining the random number generator that creates our graph. We probably want to decouple that, right? Because the problem we're trying to solve, we want to run many times. And we want to have lots of different random seeds when we're generating solutions to the same static problem. But the way we currently have it set up, when we change the random seed, we're going to have a different problem that we're solving too, and then we won't be able to compare things. So we'll have to separate that out. It also seems like this best path is continually the model's not resetting, I guess. And then it's not adding to the distance. Okay. I need to somehow reset this model. Let's see what kind of methods I have available to me in the base. Run the model until the end condition is reached. Overload as needed. Okay, this will come in handy later, perhaps. So how do you... I'm trying to figure out how to reset this thing. I'm wondering, maybe instead I'll just need to create a new one? On the other hand, like in the app, clearly there's this reset button. So the question is, how does that work, I guess? Does it create a brand new object? I could figure out how this code works, because there's like this JavaScript thing happening. Oops. Where's Mesa? Modular server. Okay, I'm going to try to dig down into the code and figure out how the reset button works. Like, what does it actually do? I'm going to guess that it's somewhere in here. Solara Viz. User parameters. Create a new model instance with current parameters in seed. Okay. It looks like it just creates a new instance of the class instead of like calling some method to restart it. Reset counter. use memo. I have no idea what that is. I know Solara is like its own framework that we could dig into, but I'm trying to make this quick. Reseed. Play button. Okay. We have play, stop, reset. We just looked at the play button. What method was this? Where are we? With. Okay. Oh, reset to reset. Reset counter dot value plus equals 1. What? All right, where is this used? Go to references. Counter to trigger model reset. All right, 1, 2 is the fourth argument to model controller. Okay, I don't really know how Solara works. I think that's stopping me from totally understanding this. But I think based on this, it seems clear that there are multiple cases that will trigger the creation of a new model. One of them is related to reset. And instead of changing some aspect of an object, it just creates a new object. So we should do the same. Let's go back to our app and we will do that. Where should we do this? For now, I'm going to not return the model. We'll have to return something here to keep track of results. But obviously this thing is being modified in place currently, so we don't need to return it. And then here we'll create a new one. Okay, let's see if this gives us what we want. We should not see this thing. We should see a path of length 20. Okay. see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I don't know why it has two 19s here. Is that a bug? I'm a little confused by, I think I'm printing this too many times. 8.79, okay. New best distance. These are the same number. That's why. Okay. And we are getting different answers here, so some random seed is changing. Okay. I think we're getting what we want. Now what we need to change is the randomness of the graph we create is separate from the randomness inside of our model. So I want to pass the graph in. That'll give us two advantages. One is we'll have a single graph that we can run a lot of iterations on. The second is that that can be the interface between runs. So we can have our graph where we have the various properties that we already have, right? So in this create graph method, we add in this distance and this weight property on the edges. We can also add a pheromone strength property or something that we calculate based on the results from the iteration. So I think the easiest thing to do is to just pull this out. Let's see, how is self used? Okay, it's only used to set the position, and we don't need to do that. We can just return the position and then set it. Okay, so let's pull this function out, and then we can call it from our other code and then pass G in. Okay. Okay. Let's see here. All right, create graph. Now I need to somehow set the random seed here. Okay. Okay, so now I have the graph and the node positions. I need to change the API of the model to take that. So this needs to go away. I know I use that somewhere, I can't remember where right now. So I'll go ahead and set that. Okay. Ah, wait a second. That's not what I wanted. I want to pass the graph in, right? That's the whole point of it being the interface. Okay. Sorry, I got myself confused there for a second. Okay, adding some type annotations. I'll have to update my app now to basically do the same thing as this. What do we call it here? G and POS. This is a little ugly, but bear with me. Okay. Where's our app? What's happening? Not sure why this is taking so long to run. Usually not a good sign. Starlet. Okay. Let's try that again and pretend that didn't happen. Something isn't working. Okay, let's see if we can get this to run. Okay. Wait, I still didn't fix it. Oh yeah, okay. Hmm. Now, why does it seem like it's doing the exact same thing every time? Let's see here. Is it creating the same? How does it do the seeding here? Is it creating the exact same seed every time? I remember there was something about setting a seed. Run model, staff advanced time, reset randomizer. Okay. Then I can pass in a seed here. What is going on? Okay, I'll just change the seed to the episode number, which will change. Hopefully we'll get some variation now. Nope. I do not understand why. Let's print out the results of each one. Okay, let's look here. We have episode 1, 1906. That sets the new best. Episode 2, 17. That sets the new best. Episode 3 is 20. And then it bounces back up to 19, so we have 17. Let's see, 02. Okay. We're not getting the exact same solution every time. And I guess this is just the variation we expect. That the variation in the minimum distances isn't as large as the variation of all distances, which is, I suppose, what I'm accustomed to looking at. Okay. And it very quickly finds it. All right, cool. So I think we have all of the pieces we need now. We have a static graph that we get from this. We can then run many times. I want to see what happens when I don't set that seed. Do I get identical? Whoops. (1906), and then it finds 17. Okay, so it seems like this reseeding manually isn't necessary, which is good. I'll leave that commented in case we need to revisit it.